review today, we're going to be looking at our exponential functions unit. And first we're starting off with exponent laws. So with our exponent laws, the thing we need to remember is that we need to have the same base in order to use these laws. Okay, so our multiplication, we have x to the exponent 3 times x to the exponent 4. Because these have the same base of x, we can add the exponents. So this is x, 3 plus 4 as our exponent, which gives us x to the exponent 7. Okay, looking at this next question, you want to multiply all of the coefficients, the numbers that are in front, and then you're combining the powers that have the same base. So first we can do our 3 times 4, which gives us 12. And then we're going to combine our exponents when we have the x as our base, so that's 7 plus 9, and combining with y as the base, so that's 2 plus 8. So this gives us 12 x to the exponent 16, y to the exponent 10. Okay, now our division law. Again, we need the same base in order to simplify here. So with multiplication, we're adding the exponents. So with division, we are subtracting exponents. So the first one, we have b to the exponent 10 divided by b to the exponent 3. So that's b 10 minus 3 gives us b to the exponent 7. The next one, we want to divide the coefficients, divide the base a, and then divide with the base b. So 40 divided by 10 gives us 4. A to the exponent 12 divided by a to the exponent negative 2, so that's 12 minus a negative 2. And b will be to the exponent 6 minus 3. So when we simplify that, we get 4, a to the exponent 14, b to the exponent 3. Our next law we're looking at is power of a power. So that's not having two bases side by side, that's just having the exponents side by side here. So when we have a power of a power, we want to multiply the exponents. So this first one will be x 8 times 2, which gives us x to the 16. Next one, we need this exponent 3 to go to every single piece of the term in the bracket. So that's 3 to the exponent 3, x to the exponent 5 times 3, and y to the exponent 2 times 3. So simplifying this here, we get 27, x 15, y 6. Now looking at negative exponents, these negative exponents we always want to make positive. And in order to do this, we need to flip the fraction. So this first one is 5 to the exponent negative 2. Since that's really 5 over 1, this is becoming 1 over 5 to the exponent 2. Okay, so you flip it and make it positive. From there we can evaluate. So this is 1 over 25. Okay, looking at the second one there, the first thing we can do is flip that fraction, make the exponent positive, and then that exponent 3 is going to go to both parts of the fraction. So 3 to the exponent 3 and 4 to the exponent 3, which will give us 27 over 64. Okay, and with our 0 exponent, anything to the exponent 0 gives you the answer of 1. Okay, so it doesn't matter what we have there, it will equal 1. Next, if we want to move between radical and exponential form, okay, so in our exponential form, this becomes a fraction as the exponent. So when we write our radical form, the numerator is the exponent, the denominator is the number that goes in front of the square root. So we have 5 root a to the exponent 6. Okay, this next one here, 10n to the exponent 3 over 2. The 2 goes out front, and we have 10n to the exponent 3. Okay, so you'll notice I wrote these a little bit different. We can have it in a bracket where we would have the 6 outside of the bracket, or you can have it where the exponent is underneath the root. Just making sure that that exponent goes to all parts of what is under the root. So under the root, we would need to have a bracket around the 10n to then have the cubed beside it. I'll write that one as well. Okay, those mean the same thing. Now, if we want to write in exponential form, we are going to take this radical form, the exponent here is going to be the numerator, the one outside the root is going to be the denominator. So m3 over 4. Now, when we don't have a number outside of the root, that number is a 2. Also, we know that if we don't have an exponent, there is an invisible 1 there. Okay, so this gives us 6p to the 1/2. Okay. So here we want to simplify and evaluate. So this first one is 9 to the 1/2. This is the same as saying the square root of 9, which is 3. Next one, we have the square root of 36 to the exponent 3. The square root of 36 is 6, and that's going to be to the exponent 3, which gives us 216. Okay, so depending on your calculations, sometimes it works better to do this exponent here first. Sometimes it works better to do the root first in your calculations. Okay. This next one, the first thing we want to do is make that negative exponent into a positive. So that means we need to do 1 over 343 to the 4 over 3. Making that a radical, we have 1 over 3 root 343 to the exponent 4. So when we calculate this, we're going to get 1 over 2,401. Okay, in your calculator, if you're doing a square root, you'll either have this as an option, or there won't be a number there, you'll have this. And any other option, you might have an X out in front where you need to put the number in yourself. Okay, now moving to solving equations. Reminder here, when we want to solve an equation, we need a common base. So once they're in common, we can drop the base and just solve the exponent. So the first question here, the 4 to the exponent 2x equals 4 to the 30. Because those have the same base of 4, we can just drop the base and we're going to have 2x equals 30. Rearranging, x equals 30 divided by 2, and our x value is 15. Okay, the next one, 3 to the exponent x equals 9 to the exponent 3. We need the same base, so we are going to change that 9 into a 3 squared to the exponent 3. And here we have a power of a power, so we need to multiply those exponents. So 3 to the exponent x equals 3 to the exponent 6. When we drop the bases, we just have x equals 6 as our answer. Okay, and then the final one, we have 4 to the exponent 2x equals 8 to the exponent 3. To make this a common base, we want a base of 2. So 2 squared to the 2x equals 2 cubed. Okay, so power of a power, we multiply. We have 2 to the 4x, and that is equal to 2 to the exponent 9. We have the same base, we will drop that and just have our exponents left over. 4x equals 9. When we bring 4 across, we'll have 9 divided by 4, or 9 over 4 as our answer. Okay, so next, looking at our exponential equations, we have y equals ab to the exponent x. Okay, so a reminder with our exponential equations, we can have a growth or a decay. So the a value is the starting amount that you have. The b is the growth or the decay rate. And x is going to be your time. So if we have a b that is greater than 1, it'll be a growth, and it will be a graph that looks like so. And if we have a decay, that's having a fraction as the b, or a decimal number, a number that's between 0 and 1, and the decay graph will look like this one here. Okay. If you're given a percent as your growth or decay, then you're going to have, instead of your b, you'll be writing 1 plus r for growth, or 1 minus r for decay. So we have a couple of examples here. Determine the amount in a bank account after 6 years if the account starts with $500 and has an annual growth rate of 3%. So with our y equals ab to the exponent x, we want our starting amount, which is the $500. We want our we have a growth rate of 3%, You always want to change the percent to a decimal, so that's 3 divided by 100, which gives us 0.03. And because this is a growth, we want to do 1 plus r. This is our r. Let's change that here. That's r. So our b will be 1 plus 0.03. Okay, and our x value is our time, which in this scenario, it is 6 years. So y equals 500 times 1.03 to the exponent 6. Okay, when we calculate this, we get $597.03. And our last one, you buy a new car for $35,000. The car depreciates by 15% annually. What will the value be after 2 years? So we have a starting amount of $35,000. The car is depreciating by 15%. So the rate here is 15 divided by 100, 0.15. So that means we have a decay rate of 1 minus that 15%, which is 0.85. And x being our time is 2 years. So again, in our y equals a b to the exponent x, a is the 35,000, b is 0.85, and x is 2. Okay, when you're calculating, do exponents first before the multiplying. So the 0.85 squared, then times 35,000. So what we get is $25,287.50 as the value of the car after 2 years. Okay, so you'll be working through the worksheet, and if you have any questions, please let me know.